Okay, guys, let's talk about alkenes and alkynes. And so, alkenes are going to contain at least one carbon to carbon double bond. And so that's what makes it an alkene. Alkynes are going to contain a carbon to carbon triple bond. And so, they're like alkanes, except that we have at least one double or triple bond. And so let's do a couple of examples. We'll look at the simplest alkenes and alkynes. And so here is a simple alkene. And then here, let's finish out the hydrogens for our example. And then here's an alkyne, carbon-carbon triple bond. And so one thing you'll notice is that the H's are different. And so we only have two H's on these two carbons. We only have one H on that. Remember that the carbons would like to have four bonds. And so this carbon here has its four bonds, two between the next carbon, and then two H's filling it out. And this carbon here has three for the next carbon, and then one more H. And so remember to fill out with the appropriate number of hydrogens to give it the four bonds. Don't give it 10 electrons or 12 valence electrons by adding too many hydrogens. And so you know that two carbons is a root of F. And so these are both going to have F roots. And then the fact that we have a double bond in our chain means that it is no longer an alkane, but it is an alkene in this case. In the case of triple bond, it's now an alkyne. And so we change the ending. And so this would not be ethane, this would be ethene, and this would not be ethane or ethene, it would be ethyne. And so those are our new endings. We'll end with ene or ine. Ene indicating that we have a CC double bond, and ine indicating that we have a CC triple bond. And so those are two alkenes and alkynes. And so let's do a couple of more examples of those. We'll go with, I'm just going to finish out with dashes instead of the H's just because I don't want to waste the time on writing the H's, but here we go. Again, making sure that you have the correct number of H's. So like this carbon has 1, 2, 3, 4 bonds, so we only have one H on that particular carbon. So this would be propene. It's got 3 carbons, so it's prop. There's a double bond, so it's ene. We don't have to have all double bonds, just a double bond will make it an ene. It's not that every carbon-to-carbon bond has to be double. So let's say that I drew it like this. What would that be? Well, that's also propene. It's no different than the propene that we just drew up here. We just rotated the molecule, if you will. We flipped it around. It's the same. So let's do another one. Let's go to bute. So that's going to have 4 carbons in it. And let's put the double bond right here in between the first 2 carbons and finish those out with our hydrogens. And let's draw another one. But this time, let's put the double bond between the second and the third carbon. And again, let's finish these out with the hydrogens. And so these are both butene. They have 4 carbons and they have a double bond, and so they're bute as our root and they are ene as our suffix, but they're not the same. They're not the same butene. They are different. This is 1 butene and this is 2 butene, because in this case the double bond begins on carbon 1. We number 1, 2, 3, 4. Very much like our substitutes, number with the end closest to the odd thing, in this case double bond. In this case we'll number 1, 2, 3, 4, and the double bond starts at carbon number 2. If you number this one backwards, if you go 1, 2, 3, 4, it's the same thing. It wouldn't be any different if you number from right to left in that case. Remember from right to left in this case, you'd have a 3 butene, and that's not right. A 3 butene is just a 1 butene. And so that is what we have. Now, just a note, you might also see this named, instead of 1 butene, you might see this named as but1ene or buta1ene, and you might see this as but2ene. I have also seen it used in that format where we just bring the number into the name in front of the suffix that it applies to. So this 2 is applying to the "-ine", and so we're just bringing it together with that suffix, if you will. Let's do one more, or maybe a couple more of examples, a particular different kind of type, if you will. And so, can we have multiple "-ines"? We can. We don't have to, but we can have multiple "-ines". And so here is a situation where we have multiple "-ines. And in the case of here, you might ask, well, hey, Mr. Brumage, how come you're doing like the bonds alternating, the H's on the other C's? You know, you don't have to. You could do all of them pointing up or all of them pointing down. But probably, you know, chemically, they'd actually be alternating on the double bond. But that's no big deal. We're not going to worry about that right now. And so let's number this one. Would be numbered from the left to the right or from the right to the left. Well, hopefully you can see that we would number this from the left to the right. So number our carbons that way. Now we have an "-ine" at carbon 1 and we have an "-ine" at carbon 3. And so you could name this 1, 3, just like we have been doing, like with the methyls. If you have more than one methyl, do it in both locations. So 1, 3, we have 5 carbons, so it's penta. 1, 3, penta, or pent. And we're going to add an A just so that it flows nice here, because we're going to add diene, because we have 2 enes. There are 2 double bonds in here. So pentadiene. You could bring the numbers into the name, and you might see it that way. In that case, we'd have pent 1, 3 diene. So both of those formats would potentially be acceptable. And let's just do one more thing with this. Let's just take this same one that we're looking at, and let's draw it. Let's do the condensed formula. And so we had a 1 and a 3 pentadiene. And so if we did this, if we converted this to a condensed formula, well, we have a CH2. And now here we have a what? We just have a, there's just one H here, a CH. And then here we again just have a 1CH and then another CH. And in this case, we'd have a CH3 there. And so, you know, we're just doing the right number of bonds. If you see a CH, then that might be an indication we have a double bond, unless there's some other substitute on there. So there we go. So that is a quick lesson on alkenes and alkynes.